Okay, just some statistics basics to begin with. Um, we have a normal distribution here, what's typically called a bell curve. And at the center of the bell curve is the mean of the population. Um, Lots of things um, in nature would have a normal distribution. Pretty much anything that's measurable um, has a normal distribution. The height of adult males, that would be, those heights would be normally distributed. There would be a mean, and there would be some taller people, and the taller you are, the more unusual you are, and the shorter you are, the more unusual you are. Weight would also be normally distributed. You'd have an average or mean weight, and heavier people are more unusual. The heavier you are, the more unusual you are, and the lighter you are, the more unusual you are. If you're if you weigh around the average or the mean, you're a typical weight. And this is a probability distribution as well. And the probability of weighing more than a certain amount is this little area here. The probability that weighing less than a certain amount is a little area down here. Now, this distribution, um, every, let's say we're talking about weights again. So um, this person, this weight, not a person, but this weight is fairly high in this distribution. There's a measurement. It's a weight. Now, this measurement differs from the mean weight by a certain amount. And that certain amount is called its deviation. It deviates from the mean by a certain amount. Um, Now, how do you calculate that deviation? It's very simple. It's the difference between that weight and the mean weight. It's the measurement x minus the mean weight mu. Now, every one of these measurements, this is a distribution full of practically infinitely many measurements, but really however many people there are in the population, um, this is a distribution of that many measurements. Now, this here is, if you took all these deviations, all those red deviations, the average of all those deviations would be this guy, and he has the symbol sigma. He is the standard deviation. It's pretty much the average of all of the deviations of all of the weights, or whatever's being measured. Now, these numbers along the horizontal axis here, these are counting how many standard deviations from the mean a particular measurement is. This particular measurement right here is between 2 and 3 standard deviations above the mean. It will be just as unusual, I don't know why I did that, it will be just as unusual as, say, a measurement that was to the same amount below the mean. Would be just as unusual, equally unusual in the opposite direction. So essentially, these numbers here, 1, 2, 3, or -1, -2, -3, are indicators of how unusual a particular measurement is. We measure unusualness based on how many standard deviations from the mean a particular measurement is. And we calculate it. These numbers are referred to as z-scores. And the way you calculate a z-score, it's really, all it is it's a measure of unusualness. A z-score tells you how unusual a particular measurement is, and it's simply a number of how many standard deviations a particular measurement is from the mean. These numbers up here are z-scores. So the z-score that we're calculating here is the z-score. In this particular case, if the measurement were here, it would be a z-score between 2 and 3. So how do we actually calculate that? Well, we want to know how many of these standard deviations, that green guy, it takes to get all the way out to this measurement. So it's how many of those sigmas are in this deviation. So basically it's the deviation, how many of these sigmas it takes to make the deviation. That's what division means if you think about it. How many of these guys does it take to add up to this guy on top? That's what division means. So the z-score is the deviation divided by the standard deviation. The measurement minus the mean divided by the standard deviation. And standard deviation, as I said before, is a unit of unusualness. It's like centimeters measure length, kilograms measure mass, milliliters measure volume. Standard deviations measure unusualness.